Going back to our pressure vessels, remember if we look at a point on the surface of a cylindrical pressure vessel, we have the sigma 1 in the hoop direction and sigma 2 in the longitudinal or axial direction. That was basically referencing and introducing principal stresses without even mentioning it in Chapter 8. But that's what we have here, right? We don't have any shear stress. We just have our normal stresses coming out of our two faces. So those are our two principal stresses in plane stress. So our hoop stress here is 32 megapascals, which means our longitudinal stress has to be half of that. So remember, it's PR over 2T. So that's 16 megapascals. And if we're given this stress element here, we can then find our absolute maximum shear stress at this point. So let's do it. So the way to find that absolute maximum shear stress is one of two ways. One, we can just think about what our maximum and minimum principal stresses are going to be and follow this equation where we take the largest minus the smallest divided by 2. And remember that third principal stress coming out of the page or into the page is going to be 0. So you would have 32 minus 0 divided by 2. Your absolute maximum shear stress is 16 megapascals. And that's going to occur at your sigma average between those two normal stresses, because that's going to be our center point of our circle. So that's also at 16 megapascals. Or you can just plot your three circles and see which one's your biggest and therefore has the largest radius. That's going to be your absolute maximum shear stress. So in this case, we can plot sigma 1 and sigma 2 as our first Mohr circle. So that was between 32 and 16. 32 and 16. That gives us this circle, the radius of 8. Then our other circle would be between sigma 2 and our third principal stress, which is 0, which will give us this circle, same radius as that one. And then, of course, what we already found was our largest circle is going to be between our largest principal stress, which is sigma 1 at 32, and our smallest, which is 0. So that's this circle here. And if it's 32 megapascals from 0 to sigma 1, that means our radius is going to be half that, which is 16. So again, that's 16 megapascals as our absolute maximum shear stress. And it's located at a sigma of 16 megapascals as well, right here at this point. Right? And then we mentioned that the orientation of that element is going to be 45 degrees within the plane, having only the principal value of 32. That's our plane for the big outer circle. We didn't give letters to that plane, but it's going to be 45 degrees rotated within that plane. So that would be the plane where we're looking in the direction of this 16 megapascals, where 32 would be coming out of the top and 0 out of the right and left. If you rotate this element 45 degrees, that's where your absolute maximum shear stress is going to be. And then this just mentions how we found our max in plane for the plane with sigma 1 and sigma 2, but we already know how to do that from our previous sections. All right, that's it. I'll see you over at the worksheet problem, where we do another combined loading problem, this one mostly in 2D, and then we apply this 3D Mohr circle to find our absolute maximum shear stress similar to this. So I'll see you there.